Hey, what's up, guys? Welcome to my YouTube channel. Today, we're going to talk about cybersecurity concepts. So let's jump right into it. Cybersecurity isn't just a career, it's a superpower. You'll learn to see what others miss: hidden doors, quiet alarms, weak locks in digital cities that never sleeps. Kind of remind me of New York City. But at the end of this video, you'll know why security exists, what to learn first, and how to think like an ethical hacker without crossing the line. Now let's get into it. Comment I'm in if you're getting started today. So why does cybersecurity exist? And I'm going to use a kitchen analogy because I'm kind of like staring at one right now. So imagine a restaurant. You got a front door, which is the login, a kitchen, which is the server, recipe, think of that as the data, IP, and customers, the users. Simple. So now you have attackers try to sneak through the front door, pretending to be staff, or steal the secret sauce. Kind of remind me of Plankton from SpongeBob. Security jobs is to lock doors, watch the dining room, label allergens, which is sensitive data, and make sure every plate, which is packets, is safe to serve. Stick with me. We protect the CIA triad. The C stands for confidentiality. Basically, no authorization tasting. Next one, you have integrity. No recipe tampering. Next is availability. Kitchen stays open. So you have the CIA triad. And we're going to throw in the triple A, authentication. Who are you? Authorization. What can you do? Next, accounting. What did you do? Cybersecurity exists because the internet connected everyone. An attacker only needs to be right once. We need to be right every day. So CIA, triple A, risk equals likelihood and impact. I also want to jump into the hacker's mindset, right? You want to be ethical, curious, and systematic. Now, let me elaborate, right? Let me build you a mind pillar. Curiosity with consent. Ask, what if? But only in a lab or with permission. Second, model first, tool second. Understand systems before you touch a keyboard. 3, hypothesis. Test, observe, iterate, small reversible experiments. Number 4 is super important. Note taking equals superpower. I will always refer to these things as superpowers. So, note taking, superpowers, screenshots, commands, and what worked and failed. Story thinking. Every system tells a story: who uses it, where data lives, and how trust flows. Bias check. Don't assume it's secure because it looks polished. So let's kind of do a ethical check here. 10-second rule. If you don't own it or have explicit written permissions, you don't touch it, period. Core map of cybersecurity. We're gonna call this the city tour. Okay, so you have high level domain, what exists out there. Network security, so routers, switches, firewalls, VPN, segmentation, kitchen versus dining room. Endpoint security, right? So laptops, servers, hardened, EDR, AV, patching. Web app security, HTTP, session, auth, OWASP, top 10. The classic kitchen entry points. Identity and access, IAM. Who gets what key to which door? Next, cloud security, shared responsibility, buckets, IAM roles, secrets. Blue team, SOC, logs, detections, SIEM, incident response. So basically security cameras plus alarm systems. Red team, pen test, control attacks to improve defenses, trusted food critics. GRC and risk. So policies, compliance. So basically a health code for your kitchen. Cryptic basics, hashing, encryption, digital signature, tampered seals, or containers. Okay, so what should beginners learn first? Order matters. So, phase one, foundation, 2 to 6 weeks, right? Operating system, Linux. You want to learn file systems, permissions, service, Windows basics. Next, networking, IP, TCP, UDP, ports, DNS, routing, subnets, read ipconfig slash ifconfig, pings, traceroute. The web, HTTP verbs, get, post, cookies, session, status code, HTML, CSS, JS basics, programming, Python for automation, learn variables, loops, functions, requests, parsing. All right. Security concepts, CIA slash AAA, risk, least privilege, patching, backups, logging. So then we go into phase two, right? Hands-on, 4 to 8 weeks. Safe labs, virtual machines, Kali, Ubuntu, plus a Windows box. A vulnerable target, legally provided. I'm sorry, I have to throw that in there for YouTube's sake. And a SIEM-ish tool. So Security Onion, Wazzer to watch logs. Methodologies. The kill chain, MTRE attacks. So basically how attacks move. OOPS, web risk, threats modeling, which is Stride. Tools. So we have recon. So we're going to use tools like Whois, NSLOOKUP, dig, passive OSINT. So that's public information. Then you have network. Nmap, which is discovery. And then we have Wireshark, which is traffic analyst. Web testing, consent only, obviously. Intercepting proxies to understand request and response. Blue team, log search and alerts in a SIEM, written a simple detection rule. Phase three, so specialize. So web pen testing, cloud slash IM, SOC slash DFIR, malware analyst, purple teaming, industrial IoT. So let's go back into the kitchen analogy and tie it all in, right? So ports equals doors to room, protocols equals languages staff speaks, encryption equals temper evidence wrap, hash equals small signatures for a dish, least privilege equals not everyone gets the liquor cabinet keys. Attacker flow. Recon. Learn the layout. DNS, IP ranges, public tech stack. 2. Initial access. Phishing, exploit a weak door, steal key. Credentials. 3. Persistent and privilege. Hide a spray key, escalate access. Number 4. Lateral movement. Walk through connected rooms, shares RDP. 5. Action and objective. Steal recipe book, data, and sabotage stove, ransom. 6. Exfiltration and cover your tracks. Box it up and slip out. Defender mirror. So basically prevent, which is patch, harden, MFA, least privilege. Detect. Logs, EDR, SIEM. Respond, isolate, investigate, eradicate, recover, improve, lesson learned. So you want to also create a mini demo idea. Show an HTTP request in plain English. Basically, hi server, I'm getting /log. Here's my cookies. The server replies 200, which is okay, meaning welcome back. Then ask, what if the cookie is stolen? Explain session at a high level. Building your first home lab. What you will need. Computer with 16 gigabyte plus RAM, more helps obviously. 100 gigabyte of free storage. Virtualization, which you can use VirtualBox or VM. VM was where I'm at because we're not gonna get into that. VMs, Kali or a standout Linux distro. It's gonna basically be your toolbox. Ubuntu server to harden and monitor. Windows 10, 11 to learn Windows internals, policy, monitoring, Security Onion or Waza, See the camera feed of your network. Targets. Practice only intentionally vulnerable machines or local containers, never random sites. So first exercise, you're gonna map out your own lab network with Nmap, right? What services do your own VM runs? Spin up a tiny web app locally. Watch how HTTP traffic intercept proxies to learn the request and response cycles. Generate a fail benign in Windows and find it in your SIEM. Write a simple Python script that fetches a page, count status codes, and log in the results. Safety checklist. Lab is offline or segmented. No scanning anything you don't own. Keep notes of every change so you can revert. Your 90 days roadmap. Day 1 from 30. This is foundation and habit. So Linux one-on-one, files, permissions, services. Windows basics, user, service, event viewer. Networking crash course, subnets, ports, DNS. Python fundamentals, request, file input and output. Daily 45 to 90 minutes, 20 minutes theory, 40 minutes hands-on, and 10 minutes notes. Build your lab, document everything. Day 31 to 60, offensive and defensive basics. Web fundamental plus OOPS concepts, so input validations, auth, and sessions. Network discovery in your lab. Protocol reading with Wireshark. SIEM practice. Write 2 to 3 simple detection, mainly failed logs. Start mini cases. Create an incident in your lab and respond to it. Day 61 to 90 days. Choose a track. Web examiner, so focus on HTTP, session, access control, and practice against legal targets. Blue teamer. Logs, detection, triage playbook. Emulate benign attack with your lab. Next, we have cloud IM. Basic IM roles, policies in a free tier. Least privilege exercises. Publish weekly summaries. So GitHub portfolio. That portfolio is your evidence. So always remember, consistency beats talent. Your notebook and your lab time is where it's really at. You're not hacking. You're modeling trust. You're not breaking things. You're improving resilience. You're not just learning. You're building a career moat. Confidentiality protects the receipt. Integrity, don't change the receipt. Availability keeps the kitchen open. Mindset, curious, ethical, systematic. Make sure you like, comment, and subscribe so I know that you guys are enjoying this content so I can make more and better ones for you guys. Thank you for supporting. I truly appreciate it. See you until next time.